Welcome to the next part. In this part, we have to discuss the shape of molecules or the shape of some electron arrangement, which already discussed in the last part. Okay. So first of all, you can start with the shape AB2. AB2, which means linear shape. Linear shape. Okay. The linear shape where the central atom is A and which is surrounded by two B's like this. Okay. Where the bond angle between these two bonds, angle between two bonds are said to be bond angle. In case of linear shape, the bond angle is 180 degree. Ready? And let me have an example, BeCl2. Okay. So what about the shape of BeCl2? BeCl2, the shape will be like this. And here will be a 180 degree. So this is first geometry, linear. Okay. Moving to the next shape, number 2, that is AB3, right? AB3. Well, the shape is called trigonal planar. Trigonal planar. Okay. So what about the trigonal planar shape? Central atom A and three bonds which are arranged in the three corners of equilateral triangle like this. Okay. And this is the periphery. This is a shape actually. But the angle between a bond and a bond is 120 degree. Okay. This is actually the shape of AB3, trigonal planar shape. And we have an example, let it be BF3. BF3. Okay. So the central boron surrounded by three fluorines in a trigonal planar fashion with a bond angle 120 degree. Okay. So this is the shape AB3. So moving to the third shape, that is AB2L. AB2L. Two bond pair and a lone pair. Ready? Listen. And the shape what we called as bent, angular or V shape, right? We know that. So let's check what about the shape. Here the central atom. Central atom is A. Where the geometry is very same. What? Where the geometry is very same. Triangle planar, where these two are bonds and this is a lone pair. Okay, so it's equivalent structure. This is how the AB3L. So the geometry till it is what? The lone pair can be drawn like this also. So geometry the very same, trigonal planar, but due to the lone pair, its shape will be a bend shape. Shape means it is a shape between bonds. Okay, shape between bonds. Ready? So shape between bonds, you simply check that there is a bend. Bend. Or this is a letter V, inverted V shape or angular. Okay. Ready? So for the example of this molecule, we can give the example for this molecule as SO2. SO2. SO2 have an angular structure like this. Okay. This is the structure of SO2. Okay. There is one limitation. In case of VSEPR theory, a multiple bond which is treated as a single bond. Okay. A bond pair means it may be a multiple bond or a single bond. Okay. A VSEPR theory is not able to distinguish whether the bond pair is a multiple or single. Okay. That is one of the failure of VSEPR theory. So we have to know that Here, two bond pair and a lone pair, but the two bond pair, each bond pairs are a double bond. Okay, simply two bond pair means here actually four bond pairs are there. 1, 2, 3, 4. Okay, between two atoms. So this double bond which is treated as single bond in case of VSEPR theory. That is a limitation of VSEPR theory. Ready? So you have to know what is whether the bonds are double or single. Then only you can predict the structure. Fine. Okay. So this is the structure of what? SO2. And the bond angle which is nearly given as 119.5 degree. So there is a small distortion of bond angle. Actually the bond angle will be 120 degree, right? But the distortion is that here is an additional repulsion. Here is a repulsion. Here is a repulsion between lone pair and bond pair, right? So due to the repulsion between lone pair and bond pair, and there are also a repulsion between what? Fine. Let me show that in here. Here actually two bond pairs and lone pairs. So there may be a chance for the repulsion between lone pair and bond pair. Okay. So which is comparatively stronger than repulsion between two bond pair, right? So in order to reduce the strain or in order to increase the stability, they try to reduce the greater repulsion compared to the lesser one. So they try to reduce the lone pair bond pair repulsion so that two bond pairs get at close where its bond angle have a small decrement. So expected bond angle is 120 degree, but it is actually 119.5 degree due to that particular repulsion. Okay. So this is a structure called AB3L. Ready? Move to the fourth one. That is your AB4, right? AB4. AB4, the shape called tetrahedral. Ready? Fine. So let me represent the structure tetrahedral. Central atom a bond B, a bond B, a bond B, another bond B. Okay. So this is a structure tetrahedral. This is a structure called tetrahedral. Ready? Well, the bond angle here is 109.5 degree. 109.5 degree. Actually, that is 109 degree 28 minutes. But we know that 30 minutes is 5 degrees. So nearly 109.5 degree. So this is a structure tetrahedral. Okay. Or let me show an example. The example is methane. The example is methane. So what about the structure of methane? Having a tetrahedral structure like this. Okay. You are not asked to draw the structure, right? Because you are dealing with the objective question. But you have to know, you have to identify the structure, whether it is tetrahedral or trigonal planar like that. Okay. For that, you have to know some idea. Okay. So this is the structure AB4. Moving to the next geometrical variation in the very same VSEP4. That is 5. Is it 5? Yeah, 5. AB3L. AB3L. The shape is AB3L. Ready? AB3L, we know the shape called pyramidal, where the geometry is very same, tetrahedral. Okay. So that AB3L, which is like 3 bonds like this, and here is a lone pair. Here is a lone pair. So this can also written or draw like this. So the geometrical pattern is actually what? Geometrical pattern is actually tetrahedral, but due to the variation or due to the presence of lone pair, what happened means the presence of lone pair. This is not considered in the shape. This is the shape. So the shape is something like a pyramid. That's why the shape is called a pyramidal shape. And a well-defined example here is NH3. So if you are considering ammonia in pyramidal shape, will be like this. Okay. So moving to the next. Next, number 6, AB2L2. AB2L2. AB2L2, the shape is before that, in case of ammonia, the bond angle is 107 degree. Actually, the expected bond angle we know in case of tetrahedral, that is 109.5 degree. So 109.5 degree bond angle is reduced to 109 degree. And what is the reason means, here compared to the pure geometry tetrahedral, here is a lone pair, right? Here is a lone pair. And that lone pair and bond pair have a repulsion relatively greater than repulsion between bond pairs. So the exactly same reason which is discussed in the previous section, the bond pairs get closed in order to reduce the repulsion. When the bond pair get closed, there is a maximum distance between that creates a maximum distance between lone pair and bond pair, where the repulsion will be relatively decreased. So the next category, that is AB2L2. AB2L2, the shape very similar, bent, angular or V shape. Okay, so that shape is something like this. A, here is a B, I'm sorry, here is the lone pair, here is the B, here is the B, here is the lone pair. Okay, so what is the speciality here is, here creates all kind of repulsion. Bond pair, bond pair, bond pair, lone pair, lone pair, lone pair. So due to the repulsion between lone pair and lone pair, the lone pair get maximum distance, so that this geometry become nearly something like this. Lone pair get maximum distance. Okay, lone pair occupies some maximum distance. Then the bond pairs are like this. Okay, so let me show that like this. So due to this repulsion, the actual structure will be like this, but due to this repulsion, the structure have a maximum stable arrangement like this, which creates the bend shape. So a lone pair like this, a lone pair like this, a bond pair here, a bond pair. This is a shape called a bend shape. Okay, this is a shape where the shape between bonds are bent, again bend or we like that. Okay, where we can give an example here as water. Water have a bend shape. Okay, so we all know the structure of water, where the bond angle is reduced to 104.5 degree. Actually, the expectation, the geometry is tetrahedral, the expectation is 109, but the bond angle is 104.5 degree. So nearly 4 degree are decreased. Nothing but it is due to these two have greater repulsion. So this may arrange in a maximum distance. When this may arrange in a maximum distance, there develops lone pair bond pair repulsion. So in order to reduce the lone pair and bond pair repulsion, lone pair and lone pair bond pair repulsion, the bond pairs itself sacrifice its distance, and they decrease or they reduce the distance and bring to closer, right? So the expected bond angle may decrease to 104.5 degree. Okay, ready? Okay, so in order to reduce the LP-LP repulsion, LP-LP repulsion, the bond pairs are sacrificed their relative position, and they brings closer to form least distance. That's why the bond angle is decreased more. Ready? So the next shape, that is the next category, that is AB5. 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 AB5, the shape called trigonal planar. The shape is called, trigonal bipyramidal. Trigonal bipyramidal. Now what about the shape trigonal bipyramidal? Central atom A and 3 bonds are in the direction of in the direction of triangular corner, okay, which are at 120 degree, and one bond, if this is in this plane, then another bond is here and another bond is the beyond the plane. Okay, so that we can draw like this. Ready? And this bond is said to be axial bond. Axial bond. Okay, and this bond is known as equatorial bond. So there are actually 3 equatorial bond and 2 axial bond. Where the bond angle between axial bond and equatorial bond is 90 degree, where the bond angle between axial and axial bond is 120 degree. Okay, so this is the actual shape of what? Actual shape of AB5. AB5. So here is a B, here also a B. Okay, where this is little bit longer. What? Axial bond is comparatively longer than equatorial bond. Ready? So 3 axial bond and 2 equatorial bond. Two axial bond of 90 degree and 3 equatorial bond of 120 degree. Okay, fine. And if we consider the example of PCl5, then PCl5 satisfies the trigonal bipyramidal shape. What about the shape of PCl5? Something like this. Okay, ready. So we have to represent the 4 variations in that geometry. 4 variations. So 3 more variations. Seesaw, T-shape, trigonal planar. Sorry, linear. So first you know a concept. If you are introducing lone pair to, that's a point, you write, copy that. If lone pairs are introduced in trigonal bipyramidal geometry, then they occupy equatorial position. Okay, so in order to bring lone pair in trigonal bipyramidal geometry, they should be in equatorial position. Okay, if it is in equatorial position, then there creates a maximum distance of 120 degree. If it is in axial position, the angle between bonds will be 90 degree. So distance decreases means if lone pair in axial position with a small 90 degree difference makes greater repulsion. So it is better to supply lone pair in axial position so that it can bring 120 degree difference, which reduces the repulsion. Okay, ready? So keep that point. Keeping that point, let me draw the next structure, AB4L. AB4L. AB4L means AB4L, the shape is called seesaw. The shape is called seesaw. So A is here, and we know this is a geometry. Ready? Where if you want to introduce a lone pair, then that lone pair is in the equatorial position. So these all others are in axial position. So this is the actual shape called a seesaw, or it can be like this also. Here is a lone pair. So if you consider the shape, then it is something like a seesaw. Seesaw. Okay. So F sub 4 is a molecule which satisfies the seesaw shape. Lone pair, fluorine, fluorine. I'm sorry, that's wrong. SF4 is a molecule which satisfies the seesaw shape. Okay. So SF4 is, here is a lone pair, here is a fluorine, here is a fluorine, here is a fluorine, here is a fluorine. Okay, ready. So moving to the next, AB3L2. AB3L2. AB3L2, the shape is called T shape. So you want to introduce two lone pair. So A is here. This is a geometry. You want to introduce two lone pair. If you want to introduce two lone pair, then you place that two lone pair in this position. So here is a bond, here is a bond, here is a bond. And the example for that is ClF3. If you are showing the ClF3, what happened? Here is a bond, here is a bond, here is a bond. And these two are lone pair. Okay, ready. So you check the shape of bonds, that's T shape. Ready? Moving to the next, AB3, I'm sorry, AB2L3. AB2L3 have a shape of linear shaped. Okay, that linear shape is like this. A is here. Okay, so you want to introduce three lone pair. So the three lone pair in equatorial position and the two bonds are in linear pattern. So example is XCF2. So let me show the linear structure in XCF2. So here is a lone pair, here is a lone pair, here is a lone pair. Only the bond is in a linear pattern. So bond is linear pattern. So the shape is called linears. Okay. Where the well-defined bond angles are not given for these examples. Okay. Ready. The next is AB6. AB6, the shape is called octahedral. Octahedral means there is a center point where if this is a square, a bond is here, another bond is here, another bond is here, another bond is here, and a bond is to the outside and a bond to the beyond the plane. Okay, that is the structure, octahedral. Okay, so central atom A, 4 bonds are around corners of cube, and one is to the out of plane, another to the beyond plane. So this is a structure octahedral. Okay, and SF6 is a molecule which can draw in octahedral pattern. Okay, for the all bond angles are 90 degree here. All bond angles are 90. All angles are 90 degree. Okay, and their relative geometrical variation AB5L, square pyramidal. Square pyramidal is the shape. Square pyramidal means you know what is octahedral shape, then you simply introduce a lone pair there. So octahedral shape, introduce a lone pair on the top. So all others are bond. So this is the shape of octahedral. Sorry, square pyramidal. Let me show the example with the BR of 5. Then a BR, a bond here, a bond here, a bond here, a bond here. Here also a bond of fluorine. These all are 5 fluorine bonds. Okay, in the top there is a lone pair. Okay, the accurate bond angle is not given in your textbook, so there is no need to study that. Okay, the next structure is square planar. Square planar. So square planar, which means the structure is AB4L2. 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 Okay, so the central A. So actually, this is a geometry, but you have to place 2 lone pair here. So this is a bond pair, this is a bond pair, this is a bond pair, this is a bond pair. And we can give XCF for example. XC. So 4 fluorines are there. Okay. The idea of introducing the shape means if you see the shape in your question, then you have to realize that okay, that is linear, that is T shape, that is square planar, like that. Okay, so this is a shape square planar because the bonds are only in the four four corners of the square. Ready? The front and back have what? Front and back have lone pairs. So that's why the shape is square planar. Ready? One more category is there, AB7. AB7, the shape is called pentagonal bipyramidal. Pentagonal bipyramidal. Pentagonal bipyramidal. What about the shape? You have a central A. Ready? And A that is surrounded by 5 corners in pentagon fashion. So A, from that A, there is a B here, a B here, a B here, a B here, a B here. So in a plane of a pentagon, there is 5 bonds, and a one bonded to the here, another to the. So that we can represent like this. Okay, there are also 2 different types of bonds. This bond is called the equatorial bond, and the equatorial bond is at 72 degree. And this is as usual axial bond. So axial bond have a 90 degree. So 5 equatorial at a 72 degree, 2 axial at a 90 degree. So here lone pair introduced at equatorial position, because equatorial position have small difference in bond angle. Ready? So IF7 is the example. Example is IF7. IF7, the shape of IF7, you have to show the shape like this. Adding a fluorine here, a fluorine here, a fluorine here, fluorine here, fluorine here, another fluorine here, another fluorine here. Okay. So next, the last shape that is AB6L, distorted octahedral, which means this actually a variation of what? Actually, that's a variation of pentagonal bipyramidal. So the shape is something like this. So here is the A. So you have to introduce a lone pair to the pentagonal bipyramidal. Then you have to introduce the lone pair in axial position, because axial position have a maximum distance of 90 degree. Equatorial position only 72 degree. So equatorial position should arranged with the bonds. Arranged with the bonds. For axial position should occupy the lone pair, because they have a maximum distance of 90 degree. Example is XCF6. Example is XCF6. Okay. Now need to by heart the examples. You simply realize the structure of all category. Okay, that's enough now. You may have a idea about the structure. So this is a structure at CF6. Okay, so that's all about the all different types of geometrical shape of molecules, which is discussed in the last part. Okay, so we can discuss the limitation of valence VSEPR theory followed by valence bond theory.